All right, lesson 2 in exponential functions. So remember that we had this paper folding activity in the last lesson. Let's take a closer look at that and how we would graph it just by looking at the equation. Okay, so I mean, we can plug that straight into the calculator and we know what it looks like. But let's look at it a little bit closer. First of all, remember this is your exponential equation. There is a parameter a. What did a do? We just talked about this at the end of the last lesson. A is the y-intercept. Okay, and then if we look at b, b told us which direction that the graph would be going. Remember, if b was between 0 and 1, then we had the graph that looked like this. Okay, and if b was greater than 1, we had the graph that looked like this. Okay, so looking at the equation we're given, a is 1 and b is 2. So we should be able to make a couple of predictions. First of all, the y-intercept will be 1, and the graph will open up, or to the right, it'll go up. Okay? If we wanted the rest of the characteristics, when it asks for the characteristics, we want to list those things we did in the last lesson. Okay, characteristics, we want the x-intercept, and there are none. We want the y-intercept, it's 1. Okay, what else did we ask? We asked for what is the end behavior? Okay, it's rising from quadrant 2 to quadrant 1. What is the domain? This is negative infinity to infinity, just like it always is. And the range will be 0 to infinity, just about like it always is. Okay, let's try the next one. So it starts off with this equation. Now there's a little bit of a trick there. It says E. We don't know what E is. So look over here. E equals 2.7. This is actually a number. It's a constant. And we obviously don't know what Euler's number is or what that means. But what I would think about it is just like we know that pi is this number that people have figured out that are smarter than us, E is a similar number. Okay, it's the same number every time there's a button on your calculator that represents E. So maybe it might make sense for us to write this equation like this instead. Instead of E, let's go 2.718 dot 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 to the power of x. Okay, now when you put that in your calculator, don't put 2.718, go find the button E. All right. But we're supposed to make a prediction and graph this without using the calculator, even though you probably will have the calculator on the test. We know that A is 1 here, and we know that B is the value of E. All right, so if the y-intercept is 1, does this rise or fall? Well, E is 2.718, which is greater than 1, so my graph will look like this, going through 1. Okay, and if I want to write the characteristics again, I can write x-intercept none, y-intercept 1. Again, the end behavior is going to be from quadrant 2 to quadrant 1. Our domain is negative infinity to infinity, and our range is 0 to infinity. Okay? Now, if you weren't sure, you could grab your calculator, punch it in, see what it looks like. But I don't think we need to in this case. Let's try this one. Okay, let's compare this equation. What's A going to be? What's B going to be? A is 2, B is 5. This gives us all kinds of information. Okay, A equals 2 tells us the y-intercept is going to be 2. B is 5, that's greater than 1, so this graph is going to look like this. Okay, characteristics again. x-intercept none, y-intercept 2. This is going from quadrant 2 to quadrant 1. A lot of these things, it's the same every time. Okay, the domain is negative infinity to infinity, and the range is from 0 to infinity. Okay. All right. I'll give you a second to try this one. Pause the video. You should try it before I do it. Okay. Okay. So here's our information. There's something that was new in this one, or at least first time I'm going to answer it. Is this graph increasing or decreasing? Well, if we move from left to right, says quadrant 2 to quadrant 1. So as we move from quadrant 2 to quadrant 1, it gets smaller. It's decreasing. Okay, so that's your end behavior. This says again, no x-intercepts. The y-intercept is 9. Okay, if we did this one, our a value is 8, b value is 3/4. So because it's 3/4, I know that it's decreasing like this, and I know this is 8. By the way, be careful when you're drawing this. You should not cross the x-axis. You are saying there are no x-intercepts, so please be careful with that graph. It should look like mine does, where it gets closer to the x-axis, but it does not cross. Okay, so here are your characteristics. If it asks you for the characteristics, please list all of these characteristics. All right, the end behavior is going from quadrant 2, oh, that doesn't look like quadrant, to quadrant 1, and it's decreasing. Okay, so here's your homework for this lesson. There's no textbook stuff, it's just these couple pages here. Oh, wait, sorry, I think the homework's coming up after that. Yeah, sorry, the homework is here. Okay, so let's go back. Maybe this is something we were supposed to do. Yeah, we're supposed to do this example. Okay, we're supposed to match this. So a couple things I'm going to look at here. Look at the b value first. The b value here is, for these two, is greater than 1. So these are going to be these two graphs. Okay, now I just have to decide which one is which, and there I'm going to look at the a value. So here a is 4, here a is 2. So let's try to figure out which one is which. This has an a value of 2, so this is this one. Okay, here we have a value of 4, the y-intercept is 4, so this is equation 2. Okay, so now let's do the next two. So now here I have a value that's less than 1, so I know it's one of these two graphs. Okay, and I'm going to look at the a value. The a value is 3 in the first one, and it's 3 right here, so this must be equation 1. And in the next one, here the a value is 4, here a is 4, so this must be the third equation. That's pretty easy to do. All right, summary of our information. Here's your homework, a couple pages in the notes here, if you could finish that for the next lesson.